Section of this chapter was finding the area of a triangle and a parallelogram, which wasn't too bad. Now we're going to find the area of trapezoids, rhombuses, and kites. If I'm going to find the area of a trapezoid, remember a trapezoid is where you have two bases of different lengths, and then you have those angling sides. The two bases are always parallel to each other. So to find the area, we're going to do a half times the height, and then in parentheses we're going to add the bases and then times to the rest of the product. So let's take a look to see how that formula works. So here's my first picture. It's Nevada, and so it's asking me to find the area. So notice that this would be my height, and then my two bases would be the 205 and the 511. So if I was going to use my formula, 1/2 times the height times the quantity base 1 plus base 2, I would just plug in my numbers. 1/2 times my height, which is 309, and then in parentheses I would have my two bases that I would add, so 205 and 511. So you can type this in as one big string, but you do need to make sure you put parentheses around this addition part. So when I times all of that, I get 110,622 square miles. Make sure that you always have a label. So in this case, I would have square miles. Okay, see if you can do the got it question. So in the got it question, it's asking me to find the area of a trapezoid. And so I need to set up my formula where I would do 1/2 times my height, which is 7, and take it times my quantity of my bases, so adding together 12 and 15. When I do that product, you should be getting 94.5 centimeters squared. Again, make sure you have a label on the end there. Okay, those aren't too bad. So when it's pretty straightforward that they give you everything, not too bad. The next problem is they may not be giving you the height. So here is my picture, and it's asking me to find the area, but I have this base, which is 5. I also have this base, which is 7, but notice they did not give me the height. So I just drew in the height over here. Notice that they gave me this angle P, which is 60 degrees. 60 degrees is significant because my height is always perpendicular to my base. So this is a right triangle that is formed right here. And so now this has become a 30, 60, 90 triangle. So remember, we spent time practicing those formulas. Those formulas were, I thought I wrote them down, sorry. Those formulas were the hypotenuse equaling 2 times the short leg, and the long leg equaling square root of 3 times the short leg. So if you're not remembering those, you might pause and make sure you can write those down. So in this case, they give me a right triangle, but they didn't give me any lengths as soon as you're looking at it. But you kind of have to do some inductive reasoning, meaning what they gave me was if I draw in my height here, I've now made this a rectangle, which if this side is 5, then this length over here is 5. So since this length that I've cut is 5, the remaining has to be 2, since these two have to add up to 7. That will help me at least get started because now I know one of my lengths. So if I were to label in here, this angle up here would be the 30 degrees, this would be the 60, and this would be my right angle. So remember, the short leg is opposite the 30-degree angle, so that 2 is my short leg. So if I wanted to find my height, it's opposite of 60, so that would be my long leg that I'm looking for. So that formula, there would be long leg equaling square root of 3 times my short leg. So I would do square root of 3 times my short leg, which is 2. So I could write it as 2 square roots of 3 if it wanted me to keep it in radical form. Or I could change it to a decimal if in the directions it said decimal form. Now in this problem it doesn't say, so I'm going to show you both ways. Okay? So what I've done over here is now I'm going to plug in 2 square roots of 3 for my height. Now if it said decimal, I would just go ahead and put in the decimal form of that product right there. So you're still going to do the same thing. I'm going to put in my height times the quantity of my two bases, which is 5 and 7. So here's where you're going to do order of operations. So I'm going to add these two and get 12. And then I went ahead and times 1/2 and 2. Remember, there's an invisible times sign in between that 2 square roots of 3. So don't think that they're always having to be connected, because they are actually timesing. So I can times in any order that I want to. So I went ahead and times 1/2 times 2 and got 1, but I didn't write the 1 out in front there. So if I was going to write it in radical form, this would actually be done. I would just put the whole number first. So I would write 12 square roots of 3 and then meters squared. If it wanted a decimal, then you could either change this part to the decimal if you wanted to, or you could times down here. So it's really your preference. It will make a difference which one you do, because you will get a rounding error if you do it up here versus down here at the end. So I would try and encourage you to try not to change it to a decimal until the very last moment. So I didn't change it until the very last moment, which is why I got 20.8 meters squared. If you change this up here, it will have made an effect on it. Alright, so that's pulling back in that 30, 60, 90 triangle, right triangle. So let's see if you can do the next one by yourself, but you're doing a 45, 45, 90. Okay, so on this next problem, I'm not doing 30, 60, 90, I'm doing 45, 45, 90. So what I did is I copied over the same picture, I crossed out that 60 and put in a 45, and then we already talked about on the previous that from there to the height should be 2 meters. So remember that that means that this is 45 and that's 45. So remember, my formula is going to be the hypotenuse times the square root of 2 times the short leg. That one's a little bit easier than the other one. So this 2 is my leg, so I would just be putting 2 in there to times by the square root of 2. So for my hypotenuse, wait a minute, I just realized that I had that wrong. The hypotenuse would be 2 square roots of 2, but I don't need the hypotenuse, because that would be this piece over here. I just need this height. So the height would also be 2. So in this case, my height is just 2 because that's my short leg. It didn't ask me to find the hypotenuse part. So if I plugged in 2 for my height and put in my bases, this would just times to 1, and then I could just times 1 and 12, which is just 12. So either way, you should be getting a nice whole number for that one. So let me recap, because I know there was some confusion in there. So this was a 45, 45, 90 triangle. It was asking me to find the height, which is also a leg. So that means that these two have to be the same, even though in my picture it doesn't really look like it. So since this is 2, my height has to be 2. So you really didn't have to do any in the formula on this particular one. So I plugged in 2 for my height, times those out, added my bases, and then times them, so my answer should be 12. Okay, so we've taken care of trapezoids, and then the last piece is where you can find the area of a rhombus or a kite. So either one, I use the same formula, which is a half times the length of one of the diagonals times the length of the other diagonal. So remember, a diagonal is where you have connected from one vertex to the other side inside the shape. Okay, so here is my first problem, where I have the area of, it's asking me to find the area of a kite. So it gives me my diagonal here, but it tells me different lengths, and then gives me my second diagonal there. So I would just add them to find the total length. So one of my lengths would be 6, the other length would be 7. So I could just plug in a half times 7 times 6, and then just solve it out. So I should be getting 21 meters squared. See if you can do the next one. So the next one, they're also giving you a kite, and they also went ahead and just gave you the diagonal, so it should just be plugging in those numbers. So a half times 12 times 9, which would be 54 square inches. Now, Some of these problems are pretty straightforward. Some of them require a little bit more work, like the 30, 60, 90 triangles. There will also be some problems where you have the rhombus or the kite, and you have to do a little bit of inferring from what we did in the past about rhombuses, keeping in mind that those diagonals should be bisecting each other, so they should always be congruent if they're bisecting on those equal parts. Okay, go ahead and start your assignment.